The Great Dike engineering solution to political crisis. The waters of crisis. In the year 1449, as the summer rains fell with unprecedented fury upon the Valley of Mexico and the sacred waters of Lake Texcoco rose beyond all memory and prediction, the Triple Alliance faced its greatest existential threat, not from enemy armies or tribute rebellions, but from the inexorable forces of nature that threatened to reclaim the engineering marvel of Tenochtitlan and plunge the entire imperial system into chaos that would destroy decades of political consolidation and territorial expansions, while revealing the fundamental vulnerability of human civilization to cosmic forces beyond political control. The catastrophic flooding that began during the reign of Moctezuma Ilhuicamana represented more than merely meteorological disaster, but rather a comprehensive political crisis that tested every aspect of Aztec governmental capability while forcing unprecedented cooperation between traditional rivals whose competing interests and mutual suspicions had previously prevented the large-scale collaborative efforts that would be necessary for addressing regional challenges requiring unified response and coordinated resource allocation. The engineering challenge that confronted imperial administrators included not only the immediate threat of continued flooding, but also the long-term requirements for flood prevention and water management that would enable sustainable urban development within the unique lacustrine environment of the Valley of Mexico, while creating technological solutions that could support continued population growth and economic expansion despite environmental constraints. The political dimensions of the flood crisis revealed fundamental weaknesses within the tributary system that governed imperial relationships between dominant and subordinate communities, while demonstrating that mutual dependence rather than mere military domination provided the most stable foundation for sustained political cooperation and coordinated policy implementation during emergency situations that threatened collective survival. The immediate damage assessment that followed the initial flooding included systematic evaluation of destroyed infrastructure, disrupted agricultural systems, and displaced populations throughout the affected region, while calculating the economic costs and social disruption that would result from continued environmental instability and the strategic implications of imperial vulnerability during periods of natural disaster that could encourage enemy opportunism. The emergency response measures that attempted to address immediate flooding included mobilization of available manpower for construction of temporary barriers and drainage systems, while implementing rationing procedures and evacuation protocols that could maintain essential services and protect vulnerable populations during extended crisis periods that exceeded normal administrative capabilities and resource allocation systems. The consultation processes that sought expert advice regarding flood control solutions included diplomatic missions to communities with relevant experience in hydraulic engineering, while gathering technical knowledge from various sources throughout Mesoamerica and analyzing previous flood events to identify effective countermeasures that could be adapted to local conditions and implemented within available resource constraints. The resource allocation decisions that determined imperial priorities during the crisis included difficult choices between immediate relief efforts and long-term infrastructure development, while balancing competing demands for labor, materials, and financial resources among various projects and communities whose needs exceeded available capabilities despite mobilization of unprecedented human and material resources for emergency response activities. The labor mobilization procedures that assembled necessary workforce for flood control construction included coordination between multiple political authorities whose cooperation was essential for successful project completion, while implementing management systems that could organize and direct massive numbers of workers from diverse communities with different languages, customs, and administrative traditions that required careful integration. The technical planning activities that designed appropriate engineering solutions included surveying of affected areas to determine optimal locations and specifications for flood control structures, while developing construction methods and material requirements that could be implemented within existing technological capabilities and available resources, while ensuring long-term effectiveness and maintenance requirements. The diplomatic negotiations that enabled collaborative construction efforts included complex agreements regarding cost-sharing, labor contributions, and authority relationships between participating communities, while establishing precedents for future cooperative ventures that could serve as models for addressing other regional challenges requiring multi-community coordination and resource pooling beyond normal tributary relationships. Symbolic significance that attached to successful flood control included demonstration of imperial technological capability and divine favor, while providing tangible evidence of effective leadership and administrative competence that could strengthen political legitimacy and popular support during challenging periods that tested governmental effectiveness and social cohesion under extreme pressure and adverse circumstances. The alliance of necessity, the unprecedented scope of the flooding crisis forced traditional enemies and political rivals throughout the Valley of Mexico into reluctant collaboration as the rising waters threatened all communities regardless of their political affiliations or military capabilities, while demonstrating that environmental challenges could transcend political boundaries and create mutual dependencies that superseded normal competitive relationship and territorial disputes. The diplomatic initiatives that brought together formerly hostile communities included carefully negotiated agreements that balanced immediate practical necessities with longer-term political concerns while establishing frameworks for cooperation that could address the flood crisis without compromising essential interests or creating permanent disadvantages for any participating community despite their different sizes, resources, and political positions. The technical coordination challenges that emerged from multi-community collaboration included standardization of construction methods, material specifications, and quality control procedures while managing communication between work crews, speaking different languages, and following different administrative traditions that required careful integration and coordination to prevent conflicts and ensure effective collaboration toward common objectives. The resource contribution negotiations that determined each community's participation included careful assessment of available manpower, materials, and financial capabilities while establishing equitable distribution of costs and benefits that could maintain cooperation throughout the extended construction period despite varying levels of community prosperity and different degrees of flood vulnerability that affected incentives for participation. The leadership coordination procedures that managed the collaborative effort included establishment of joint command structures that could direct multi-community activities while respecting traditional authority relationships and political sensitivities that might otherwise create conflicts and prevent effective cooperation between communities with histories of rivalry and competing territorial or economic interests. The labor organization systems that integrated workers from different communities included development of mixed work crews that could facilitate cultural exchange and mutual understanding while implementing management procedures that could address language barriers, different work traditions, and potential conflicts between groups with different social customs and political loyalties that might interfere with construction productivity. The supply chain coordination activities that provided necessary materials for construction included establishment of procurement networks that could efficiently gather and distribute resources from throughout the region, while implementing transportation systems that could move heavy materials across difficult terrain and coordinate deliveries to multiple work sites operating simultaneously under tight scheduling constraints. The quality control mechanisms that ensured construction standards included inspection procedures that could verify compliance with engineering specifications while implementing corrective measures for substandard work that might compromise structural integrity or long-term effectiveness of flood control. Systems whose failure could result in catastrophic consequences for all participating communities, regardless of their individual contributions. The conflict resolution procedures that addressed disputes during construction included mediation mechanisms that could handle disagreements regarding work assignments, resource allocation, and authority relationships while maintaining overall project momentum despite inevitable tensions and competing interests that arose during extended collaboration between traditionally independent and often competitive political entities. The communication systems that coordinated activities across multiple work sites included development of messenger networks and signaling systems that could transmit information rapidly throughout the construction zone, while implementing reporting procedures that kept all participating authorities informed regarding progress, problems, and changing requirements that might affect their community's continued participation and resource contributions. The security arrangements that protected workers and materials during construction included coordination between different military forces whose cooperation was essential for maintaining safe working conditions while preventing interference from communities or individuals who might oppose the project for political or economic reasons that could threaten successful completion of essential flood control infrastructure. The administrative integration challenges that manage complex multi-community operations included development of record-keeping systems that could track contributions, monitor progress, and document agreements while creating accountability mechanisms that could ensure fair treatment and prevent exploitation of smaller communities by more powerful participants in collaborative arrangements that required trust and mutual respect. The engineering marvel, the design specifications for the Great Dike represented the most ambitious hydraulic engineering project ever attempted in Mesoamerica, requiring unprecedented coordination of technical knowledge, construction capabilities, and resource mobilization while creating infrastructure that would fundamentally alter the environmental dynamics of Lake Texcoco and establish new parameters for urban development and agricultural productivity throughout the affected region. The surveying and planning activities that preceded construction included comprehensive mapping of the lake bottom topography, water flow patterns, and seasonal variations in water levels, while analyzing geological conditions and identifying optimal locations for dike placement that could achieve maximum flood control effectiveness with minimum construction costs and environmental disruption that might create unintended consequences for existing communities and economic activities. The foundation construction techniques that created stable base structures included development of innovative pile-driving methods adapted to the soft lake bottom conditions while utilizing locally available materials and traditional construction knowledge in new applications that could support massive stone and earthwork structures whose weight and scale exceeded anything previously attempted in the aquatic environment of the valley. The materials procurement operations that supplied construction requirements included systematic quarrying of stone from distant mountainous areas while organizing transportation networks that could move enormous quantities of heavy materials across difficult terrain using human labor and available technology that required careful logistical planning and coordination to maintain steady supply flows throughout extended construction periods. The construction workforce organization that managed thousands of laborers included development of specialized teams for different aspects of the project while implementing training programs that could teach necessary skills and coordination procedures to workers from diverse communities whose previous experience might not include the particular techniques required for large-scale hydraulic engineering construction under challenging environmental conditions. The technical innovations that solved unprecedented engineering challenges included development of new construction methods for underwater foundation work while creating tools and equipment adapted to specific project requirements that exceeded standard construction capabilities and required creative problem-solving and experimental approaches to achieve desired results within available technological and resource constraints. The water management systems that controlled lake levels during construction included temporary diversion structures and pumping operations that could create dry work areas while maintaining navigation channels and preventing disruption of existing communities whose continued access to transportation and water resources was essential for regional economic stability during the extended construction period. The quality assurance procedures that ensured structural integrity included systematic testing of foundation stability and material durability, while implementing inspection protocols that could identify potential problems before they compromised overall project effectiveness or created safety hazards for workers and nearby communities whose welfare depended upon successful completion of flood control infrastructure. The environmental impact assessments that evaluated ecological consequences included analysis of changes in water circulation patterns, wildlife habitats, and agricultural productivity, while developing mitigation measures that could minimize negative effects on existing economic activities and natural systems that supported regional prosperity and environmental balance essential for long-term sustainability. The construction scheduling systems that coordinated complex sequential operations included careful timing of different project phases to optimize weather conditions and resource availability, while maintaining overall progress toward completion deadlines that were critical for protection against future flooding seasons that could not be postponed or avoided through administrative measures. The safety protocols that protected workers during dangerous construction activities included development of emergency procedures and protective equipment while implementing training programs that could reduce accident risks and provide medical assistance for injuries that were inevitable during large-scale construction operations involving heavy materials and dangerous working conditions in aquatic environments. The progress monitoring systems that tracked construction advancement included regular reporting procedures and milestone assessments while maintaining communication with all participating authorities regarding schedule adherence and resource requirements that might require adjustment of commitments or allocation of additional support to ensure successful completion within acceptable timeframes. The maintenance planning activities that ensured long-term effectiveness included development of inspection schedules and repair procedures while establishing responsibility assignments for ongoing upkeep that would be essential for preserving structural integrity and flood control effectiveness throughout future decades when environmental pressures and normal wear could compromise infrastructure performance. The politics of water. The successful completion of the Great Dike transformed political relationships throughout the Valley of Mexico by demonstrating the advantages of cooperative governance over purely competitive approaches to regional challenges, while establishing precedents for collaborative problem-solving that could address other common concerns, requiring coordinated responses beyond the capabilities of individual communities acting independently. The governance innovations that emerged from collaborative construction included development of inter-community decision-making procedures and shared authority arrangements, while creating institutional frameworks that could manage complex multi-jurisdictional projects requiring sustained cooperation and coordinated resource allocation across traditional political boundaries that normally separated competing communities and limited collaborative possibilities. The diplomatic precedents established through successful cooperation provided models for future alliance building and conflict resolution, while demonstrated that mutual benefit rather than zero-sum competition could guide intercommunity relationships when properly organized and managed through appropriate institutional mechanisms that balanced competing interests and distributed costs and benefits equitably among participants. The administrative integration achievements that coordinated diverse governmental systems included standardization of certain procedures and communication protocols while maintaining respect for local autonomy and cultural traditions that enabled effective collaboration without eliminating beneficial diversity in governmental approaches and community customs that contributed to overall regional strength and adaptive capability. The economic benefits that resulted from improved flood control included enhanced agricultural productivity and urban development possibilities, while creating new opportunities for trade and commercial activity that could support increased prosperity throughout the region and demonstrate the economic advantages of infrastructure investment and environmental management that served collective rather than merely individual interests. The technological advancement processes that developed new engineering capabilities included systematic documentation and transmission of construction knowledge, while establishing training programs and institutional arrangements that could preserve and enhance hydraulic engineering expertise for future applications and continued improvement of water management systems that would be essential for sustained regional development. The social integration effects that brought together workers from different communities included development of cross-cultural relationships and mutual understanding, while creating shared experiences and cooperative traditions that could reduce inter-community tensions and provide foundations for continued collaboration on other projects requiring coordinated efforts and mutual support beyond normal political relationships. The military implications that enhanced regional security included demonstration of collective defense capabilities and coordinated mobilization potential, while establishing communication networks and command structures that could be utilized for mutual defense against external threats or internal disorders that might threaten regional stability and collective prosperity achieved through cooperative development efforts. The religious significance that attached to successful flood control included recognition of divine favor and cosmic approval for collaborative efforts, while providing symbolic validation for cooperative governance approaches that honored both human wisdom and divine will through practical application of spiritual principles to material challenges requiring both technical competence and moral commitment. The environmental stewardship principles that guided water management decisions included recognition of human responsibility for maintaining ecological balance, while developing sustainable approaches to natural resource utilization that could support continued prosperity without depleting or degrading environmental systems that provided essential foundations for regional civilization and economic activity. The legal precedents that established frameworks for inter-community cooperation included development of dispute resolution mechanisms and contractual arrangements, while creating institutional structures that could manage complex collaborative relationships and ensure compliance with agreements despite changing circumstances and evolving political conditions that might otherwise threaten sustained cooperation. The cultural exchange opportunities that resulted from sustained collaboration included sharing of knowledge, customs, and artistic traditions, while creating opportunities for mutual learning and cultural enrichment that could enhance regional civilization and demonstrate the benefits of diversity and cross-cultural interaction for intellectual and spiritual development. The hydraulic revolution. The technological innovations developed during Great Dike construction established new standards for hydraulic engineering throughout Mesoamerica, while creating knowledge and capabilities that would influence subsequent infrastructure projects and urban development initiatives requiring sophisticated water management systems adapted to local environmental conditions and community needs that exceeded traditional construction capabilities. The engineering knowledge that accumulated during construction included systematic understanding of foundation techniques, materials properties, and structural design principles, while developing analytical methods and calculation procedures that could guide future projects and enable more precise planning and execution of complex construction undertakings requiring advanced technical competence and coordination capabilities. The construction management systems that coordinated massive labor forces included development of organizational methods and communication procedures, while creating administrative frameworks that could efficiently direct human resources and coordinate complex sequential operations requiring precise timing and quality control to achieve desired results within acceptable timeframes and resource constraints. The materials science advances that improved construction capabilities included systematic testing of material properties and development of new applications for traditional materials while creating innovative combinations and processing techniques that could enhance structural performance and durability under challenging environmental conditions that exceeded normal construction requirements and demanded creative solutions. The surveying and mapping techniques that enabled accurate planning included development of measurement methods and cartographic procedures while creating documentation systems that could preserve essential information and enable accurate reproduction of successful approaches for application in different locations and circumstances requiring similar technical solutions adapted to local conditions. The water control technologies that managed lake levels and flow patterns included creation of sophisticated gate systems and channel designs while developing operational procedures that could regulate water movement according to seasonal requirements and changing conditions that affected flood control effectiveness and navigation access, essential for continued economic activity and urban development. The transportation innovations that moved massive quantities of materials included development of improved carrying methods, route optimization techniques, while creating logistics systems that could coordinate complex supply operations, requiring careful scheduling and resource allocation to maintain steady material flows throughout extended construction periods under challenging conditions. The quality assessment methods that ensured structural integrity included development of testing procedures and inspection protocols while creating standards and specifications that could guide construction activities and ensure compliance with engineering requirements essential for long-term effectiveness and safety of critical infrastructure serving entire regional populations. The maintenance technologies that preserved infrastructure effectiveness included development of inspection techniques and repair methods while creating institutional arrangements that could ensure continued operation and periodic upgrading of water control systems whose proper functioning was essential for regional prosperity and security against future environmental challenges and changing conditions. The environmental monitoring capabilities that tracked ecological impacts included systematic observation methods and assessment procedures while developing understanding of complex interactions between human activities and natural systems that enabled more informed decision-making regarding infrastructure development and environmental management essential for sustainable regional development. The training programs that transmitted technical knowledge included systematic educational procedures and institutional arrangements while creating mechanisms for preserving and advancing engineering expertise through successive generations of practitioners who would be responsible for continued development and maintenance of increasingly sophisticated water management systems serving growing populations. The documentation systems that preserved construction knowledge included comprehensive record-keeping procedures and standardized formats while creating archives and reference materials that could support future planning and enable systematic improvement of techniques and procedures through analysis of previous successes and failures in large-scale infrastructure development projects. The social engineering, the demographic transformations that resulted from successful flood control included significant population growth and urban expansion possibilities while creating new patterns of settlement and economic activity that fundamentally altered social organization and community relationships throughout the affected region as increased security and prosperity attracted migration, an investment that changed established cultural and political dynamics. The labor organization innovations that managed diverse workforce requirements included development of cross-cultural management techniques and communication systems while creating administrative procedures that could coordinate workers from different communities with varying languages, customs, and work traditions in collaborative activities requiring sustained cooperation and mutual accommodation beyond normal inter-community interaction patterns. The social mobility opportunities that emerged from construction activities included advancement possibilities for skilled workers and effective supervisors while creating new categories of technical expertise and administrative competence that could provide alternative pathways for individual advancement and community development beyond traditional hereditary or military routes to higher social status and political influence. The cultural integration processes that brought together previously isolated communities included systematic interaction and mutual learning opportunities while creating shared experiences and cooperative traditions that could reduce inter-community prejudices and conflicts through practical collaboration on projects serving common interests and demonstrating benefits of cultural diversity and cooperation. The economic restructuring effects that resulted from improved flood control included new patterns of agricultural production and commercial activity while creating opportunities for specialized craft production and trade relationships that could support increased prosperity and economic diversification throughout the region as enhanced security and transportation enabled innovation and investment in previously impractical ventures. The educational developments that transmitted technical knowledge included establishment of training programs and apprenticeship systems while creating institutional arrangements that could preserve and advance engineering expertise and administrative capabilities essential for continued infrastructure development and maintenance of increasingly sophisticated systems serving growing populations with expanding needs. The political participation expansion that resulted from collaborative governance included increased involvement in decision-making processes and shared responsibility for community welfare, while creating precedents for democratic consultation and collective problem-solving that could influence future governmental approaches and institutional arrangements beyond traditional hierarchical authority structures. The gender role modifications that emerged from construction requirements included new opportunities for women's participation in project activities while creating alternative patterns of economic contribution and social recognition that could expand women's roles beyond traditional domestic and agricultural responsibilities to include involvement in major community development initiatives serving collective interests. The intergenerational cooperation patterns that connected older expertise with younger energy included systematic knowledge transmission and skill development while creating collaborative relationships that could preserve traditional wisdom while adapting to changing circumstances and technological innovations requiring both experience and adaptability for effective problem-solving and continued community development. The conflict resolution mechanisms that managed disputes during construction included development of mediation procedures and arbitration systems while creating institutional frameworks that could address disagreements and competing interests through peaceful means rather than violence or coercion that might disrupt essential collaborative activities serving collective survival and prosperity. The community identity transformations that resulted from shared accomplishments included development of regional rather than merely local identification, while creating pride in collective achievements and cooperative capabilities that could inspire continued collaboration on other projects requiring sustained commitment and mutual support beyond immediate practical necessities. The religious integration developments that coordinated diverse spiritual traditions included creation of shared ceremonial observances and symbolic meanings while maintaining respect for different cultural practices and beliefs that enabled spiritual cooperation and mutual understanding, supporting practical collaboration on projects serving both material and spiritual purposes within comprehensive community development. The legacy of cooperation. The institutional innovations established through Great Dike construction provided lasting frameworks for regional cooperation and collaborative governance that influenced subsequent political development throughout Mesoamerica, while demonstrating successful alternatives to purely competitive or hierarchical approaches to intercommunity relationships and collective problem-solving that could address challenges requiring coordinated responses beyond individual community capabilities. The technological advancement foundations that resulted from construction experience included systematic engineering knowledge and construction capabilities while creating human resources and institutional arrangements that could support continued infrastructure development and technological innovation, serving regional prosperity and security through application of accumulated expertise to future challenges requiring similar coordination and technical competence. The diplomatic precedents that established cooperation procedures included successful models for alliance building and conflict resolution while creating communication protocols and negotiation techniques that could facilitate future collaborative arrangements, peaceful resolution of disputes through institutional mechanisms rather than military force or economic coercion that might damage beneficial relationships. The economic development patterns that emerged from improved flood control included enhanced agricultural productivity and expanded commercial opportunities while creating foundations for continued prosperity and population growth that could support further technological advancement and cultural development through investment in education, infrastructure, and innovation serving collective welfare and individual advancement. The social integration achievements that connected diverse communities included development of cross-cultural relationships and mutual understanding while creating shared traditions and cooperative institutions that could reduce intercommunity tensions and provide foundations for continued collaboration on projects requiring sustained commitment and coordinated effort beyond immediate practical necessities. The environmental management principles that guided water control decisions included recognition of ecological complexity and human responsibility while creating sustainable approaches to natural resource utilization that could maintain environmental balance while supporting continued human prosperity through careful planning and adaptive management responding to changing conditions and evolving needs. The educational legacy that preserved construction knowledge included systematic documentation and training programs while creating institutional arrangements that could transmit essential expertise and continue technological advancement through successive generations of practitioners whose work would build upon previous achievements while adapting to new circumstances and expanded requirements. The political evolution that resulted from collaborative governance included democratic consultation and shared decision-making while creating precedents for participatory government and collective responsibility that could influence future political, development, and institutional arrangements beyond traditional authoritarian or hierarchical approaches to community organization and inter-community relationships. The cultural achievements that expressed collective identity included artistic celebrations and ceremonial traditions while creating symbolic representations of cooperative accomplishment and shared values that could inspire continued commitment to collective welfare and mutual support through visual and performance arts that preserved memory and meaning of successful collaboration. The spiritual significance that attached to successful cooperation included recognition of divine approval and cosmic harmony while providing religious validation for collaborative approaches to community development and environmental stewardship that honored both human wisdom and spiritual principles through practical application of moral commitment to collective welfare and universal justice. The historical influence that extended beyond immediate regional impact included demonstration effects and knowledge transmission while creating models and precedents that could inspire similar achievements in other areas and time periods, facing comparable challenges requiring technological innovation and political cooperation beyond traditional community boundaries and competitive relationships. The eternal lessons that emerged from the Great Dike experience included understanding of human potential for cooperation and achievement, while revealing fundamental principles of successful collaboration and environmental management that remained relevant for future generations facing challenges requiring collective wisdom and coordinated action serving both immediate practical needs and long-term spiritual purposes. Through the triumph of cooperative engineering that tamed the sacred waters and transformed political crisis into technological achievement, the Great Dike demonstrated that human communities could transcend traditional limitations and competing interests when guided by shared necessity and common vision that honored both practical wisdom and spiritual values in service of collective survival and mutual prosperity. The legacy of the Great Dike thus preserved for future generations the eternal truth that seemingly insurmountable challenges could be overcome through sustained cooperation and technological innovation when communities committed themselves to collective welfare and environmental stewardship that served both immediate practical needs and long-term spiritual purposes beyond individual advantage or temporary political gain. In the end, the engineering marvel that controlled the sacred waters became a monument to human potential for transformation through cooperation, while demonstrating that environmental challenges could inspire rather than destroy civilization when met with wisdom, courage, and dedication to collective welfare that transcended traditional political boundaries and competitive relationships in service of universal principles and shared prosperity.